Okay. So the charge is 8 and 14 nanocoulomb.
Don't show me yet.
Separation is 10 cm.
Nano means 10 to the power -9. Okay, 8 times 40 times that, the charges, and then
And
divide
remember to
with
convert to meter.
4 pi
Convert to SI
epsilon
unit.
theta r square. But the 10 cm means must convert to meter. So 1 meter means 100.
So you don't want
So
to use
0.1.
epsilon now, you can use K. I don't think anything wrong. You get the same answer.
Just give me 1 minute. So that I already got thing already.
I thought you had done the question already just now where we break off.
That's a very fast only. Where answer. Hey, I get some weird value. Is it 2.87 times 10 to the power -4?
Yeah.
Is it? Oh, yeah lah, 2.9 lah.
Okay.
Okay.
Try this one. Two charges, 4 microcoulomb and 16 microcoulomb, are separated by a distance of 8 cm in vacuum. Find a point where the net force on the charge is 0 from the 4.0 microcoulomb charge. Yeah, you're using your first semester work. This is about vectors. Previously, you do about gravitational force. Now you do about electric force, the same thing, same idea. You should get 2.67 cm.
So it's almost the same question lah.
Almost the same. Yes, use the formula only.
Okay, wait answer. Okay, we have the charge, we have the radius. They want the point. What? They want the point.
Point where the net force is 0. So you just put a dummy charge there, a charge Q inside there, at the place there. That's all.
Wait, so they want they want point means that means they want the
A point where you put a charge there, there's no force. That's all.
Point where you put charge there, no force.
No force acting
So
on the
they elaborate
charge.
further. No, what they want me to find basically, they want me to find radius, is it?
No, they want to find the distance between the two charges. Where you put a charge there, there's no force on the charge will stay there.
So it's no, so you gotta put 8.0 inside the calculation lah. You have to put something else lah.
You just have to calculate the force on the charge as well. Let the charge be Q. And calculate the force on the charge, equal and opposite.
Do we know the force?
Same
Oh
formula.
no, for they telling assume force is 0, what, right?
The resultant force is 0. So playing with the formula only, that's all. Vector. Vector. Yeah, the unknown charge be Q.
Okay, so first one I find the force first, right? Like normal first at first, right? Correct.
Just find the force between the charge 4 and Q at a distance x. That's why you want to find x.
No, because why I'm asking this is because they already give 4, 16 and 8. So like do one equation first, then you do the other one, right? Something like that, right?
Just let a charge be there in the center there. Yeah. Let the charge be there. Q.
Oh, you mean compare, like
then find the force on this charge there. Test charge. Test charge Q. Let the distance be x. That's all. What's the problem? It's your first semester work.
Put it in the middle.
Calculate with charge, that's all. You have done it for gravitational force.
Oh, so it's a trick question lah.
Not trick question. Getting harder and harder.
Because I thought the F, right? So I thought you do the 4, 16 and 8 first to find the force, then you do the other one. I thought like that.
No, you want a point where you place the charge there, no force. So you have to calculate the force on the charge there. Let the charge be Q.
Oh, okay. So yeah, that
Not
means
the force
they
between the two
not
charge.
Oh.
Not the force on the net on the charge there. Not the force between the two charge.
Oh, okay. So
Where you put a charge there, there's no force on the charge. That's what you're doing.
so
So
so they
calculate the
want
force on the
the
charge.
okay. So F equals to 4 times 10 to the power 96 times 10 to the power 96 divide with 4 pi epsilon and then times with the r square. R square is R square we don't know what. So I mean 8 minus x plus x lah, right? No.
Yeah. 8 minus
Yeah.
x. No need to convert to meter. No need to convert to SI unit. When you come to this type of question,
Yeah, we don't know.
whatever unit you use, you will get the same unit back. Yeah, calculate the force due to the 16 Coulomb charge on the test charge. That's how you calculate. Just use a constant K rather than 4 pi epsilon naught. Yeah, calculate the repulsive force F. And then after that, calculate the other force, the other repulsive force. P, the force due to 4 microcoulomb on the charge Q.
So that's the answer lah.
Yeah, just calculate the two force as all on the charge Q.
Wait, are we seriously discussing the homework right now? I haven't got the
No,
book
no,
yet.
no. I not starting with the homework. I'm giving you after that. I'll send you the slide.
Okay.
I'm
You
just
mean
giving
the
you
full
some
chapter 12 slide? You mean the full chapter 12
getting you
slide lah?
to familiar with the calculation. Then you can do your homework.
Okay.
You can try the other one. Yeah, I'm just giving you to warm up to know what are the formulas to use. And then for non-net force, the two forces are equal. That's all. Yeah. To be able to get the answer. Can get the answer now.
Okay, so that means you equate it to each other, is it?
Yeah, the two forces are equal. That's how you get a resultant force 0.
Okay. Oh yeah, and then you equate it to each other lah. Yeah.
Then equate that. Then cross multiply. Can cancel the
Yeah,
K.
basically you can cut the K and Q lah.
Yeah,
So 4
cut the
x
K
square
and cut the
equals
4
to
also if you
16.
want to.
So 60. Yeah lah, correct lah. So this is what do you call the quadratic equation lah. 16x square equals to 4
Then just
bracket
take square root on both
64.
sides. That's
Yeah.
all.
Yeah, it cannot be -8. So yeah, the answer is 2.67 lah. Sure, I mean these questions all be in the slide lah, right?
Yeah. I'll send you the slide later on.
You mean a full complete chapter 12 slide?
Okay,
So is it a full complete chapter 12 slide?
we won't complete today. We will
Huh?
just do
What?
electric field, another topic, another subtopic.
Oh, you mean you'll send not the complete slide lah?
No, I just send you topic by topic after we have done two.
Okay.
Right? Why it
Yeah,
cannot be
okay, can
minus
go on,
A?
sir.
Right? Remember, when we take that as our reference, there's our x to the right, to the left is minus A, minus x. So it's minus 8 is to the left. So we look at 4 and 16, and then look at if you put your test charge there, what's going to happen between the 4 and the test charge? There's a repulsive force there. Between the 16 and the test charge, there's a repulsive force. So there's no way you're going to get attractive force on the left hand side. Same also on the right hand side. Only the center somewhere there, you get a no force, zero resultant force. To the left of the charge, or to the left, to the right of this charge, there's always a resultant force. Okay? So negative is because of our squaring. Okay, not?
1 minute. Okay, if the charge Q is a -8, okay, for example, then it's to the left, yes, correct. And in this case, the forces acting on the charge are both to the left.
Both repulsive.
So wait, so -8 is also to the left, and then the test charge Q is also going to the left. So oh yeah, it's zero lah. I mean it's the same one, right?
It's not zero. There's a resultant force there. You will never get a zero net force there.
Oh yeah,
Just
no,
trying to explain to
sorry, I
you.
didn't.
Trying to help you
Sorry, I
see.
didn't see. I didn't see the cannot. Okay. Oh yeah lah. That means
Trying
you
to help you
plus
see that
together,
it
you get
cannot
a
be
resultant force lah.
minus 8 cm. It must be between the charge, then you can get a no resultant force.
So the objective is to get a no resultant force lah.
So doesn't matter about the charge positive or negative. You place it between the two charge, you get a no resultant force, but not to the left or to the right of the charge. You won't get any no resultant force in this region or in this region. Okay?
Yeah, okay.
Okay, we try this one before we go to a new topic. Yeah, you got an equilateral triangle. You are asked to draw the vectors to show the resultant force acting on this charge there.
Oh, this is the equilateral, the 60-degree one.
That's your minus 10. That's your plus 10.
This one you have to do the resultant thing.
This one I don't want you to calculate lah. The exam they require to know how to calculate. I just want to know whether you know how to get the resultant force, direction of the resultant force.
Yeah lah, you resolve it lah. Like
Yeah,
example
your
for
homework,
-10.
your checkpoint will ask you to calculate. You can go and calculate there.
Okay, so can skip this one.
Right? So for the between the 5 and minus 10, there's a attractive force on the 5 microcoulomb. Between the 10 and 5, there's a repulsive force. Remember, the distance are the same, so the magnitude of the force must be the same, same size. And after that, you use your parallelogram. Draw your parallelogram, and that's your resultant force. Yep. Can?
Yeah, I mean you resolve it lah.
Let's look for the repulsive force of minus 10 on 5. Right? The attractive force is there. And the attractive force between the 10 and the 5, which is there. And then complete your parallelogram. That is your resultant. Right? That's your first semester work. Your homework, you have to calculate the value.
Okay.
Okay.
Oh, you want on the plus 5?
You want the force,
C.
the resultant force on the +5.
Plus
This
5.
one.
Oh, that's why you resolve it lah.
So that these two are repulsive force, that's why it's going away. Between these two are attractive force, that's why it's going towards a -10. Then you complete your parallelogram to get your resultant force.
Wait, so the black line are the attractive and the resultant is the repulsive.
This is repulsive, this is attractive.
Yeah, the blue is repulsive lah.
The blue is the resultant force.
Oh, sorry. The repulsive is the one going down, not towards the.
Repulsive is going towards the negative charge. This one. Sorry, attractive is the one going towards the negative charge. Repulsive is going away from the positive charge. This one.
I mean the down arrow lah, right?
Yeah, should be able to draw the diagram.
All right.
That's your homework. You have to do and calculate out.
Okay.
Just review with you. Okay.
Okay.
Okay, I don't think we will about it. We'll go to a new topic.
Teacher, but did I tell you this, Archer?
Yeah. What is that?
You know Sem 1, right? Sem 1.
The
past year, right? Because this is not risky, Archer, because this one they always prove it every year, you know. Archer. The section B, section C, they'll confirm ask 2 questions, one, you know, Archer, like chapter 9 to 11 one, like confirm. So that one already like got a mark already there. That's how I knew lah. That's why I could manage to score actually.
Yeah,
that's one. Like chapter 9 to 11, they always like to ask one.
Yeah, that's why you have to do all the question. No?
Yeah, but the 1 to 8, although you cannot predict, but 9 to 11, you already know section BC going to confirm come out already. Yeah. The other chapters are gamble lah, but this one we already know last 3 going to come out for sure. This is another one, is it?
No. I'm going to go to the new topic already. Second subtopic. You got 4 topics in this chapter.
Okay.
I'm just getting the other one. Hey, where is it? Yeah. Let me just sort it out. Too many things on my computer.
Yeah, give me 30 seconds, Archer.
Okay.
Oh, yes, hello, Chair.
Okay. I'm just sorting out to get the slides. Okay, it should be there now. Okay, this topic is electric field. Right, syllabus is there. Can review with it in your free time. Right, now we are looking at explain the meaning of electric field, sketch the electric field pattern for an isolated point charge, an electric dipole, uniform charge surface, So the first thing is to know what is the electric field. Right? It's a region of space where a point charge placed there experience a force. Right? If it's gravitational field, you put a mass there to detect the force. If it's electric field, you put a charge there. You see a positive charge to detect the force on the charge. Then there is a field, electric field region. Isolated, it means by itself only, no other charges around. Okay with that so far? These are terms you will encounter. Electric field, isolated. Okay, Okay. A charge, we think of the idea of a charged object, can be a charge by itself or ion or spherical charge surface. It creates. You just imagine an electric field around itself. Right? So that's electric field. Around the charge.
Yeah, I mean, yeah, charge object lah.
And it's infinite. It goes to infinity. As it becomes weaker and weaker as you go further away, which we will see later on. Right? So you can think of it as it changed the space around it. It altered the space around it. The positive charge altered the space around it. And how do we know the field exists? We show it, represent the field by field lines or line of force. Right? That's your SPM work. How do we show the line of force and measure its strength? That's what we are interested to. Okay, so I'm just reviewing your SPM work. Right? Positive charge, they all go away. Arrows on the line show the direction of acceleration or force on a positive charge. So to know this direction, you put a positive charge there, find the direction of the force. Then that's the direction of this line. Or where the charge accelerates. Right? So you have to memorize that for isolated positive charge. So you can think of it like water flowing. Right? It's electric field that's flowing out from the positive charge. Okay. Negative charge. Right? Isolated negative charge, the same thing. The field lines points towards the negative charge. Lines, you can just think of it as because the lines repel each other, they want to be as far as possible from each other. That's why they behave that way. Right? This is your electric dipole. A positive and negative charge is called a dipole, electric dipole. And just remember the line is continuous. There's no break there. It runs smoothly. Only between the positive and negative charge, there's a direct one, straight line. So it always leave the positive charge perpendicular and enter the negative charge perpendicular. Right? You can think of the positive charge as the source of the line, negative charge as the sink. They do not cut each other or they do not intersect. Right? You can see that, not cutting each other.
Yeah, there's no cutting.
Where they are close together, the magnitude is larger. That means near the charge is strong, further away from the charge is weak because they are far apart. As I say, it starts from the positive charge and on the negative charge. And the line is continuous. There's no break there. Like water flowing, that's all. Right? It's just pattern of flow, that's all. The lines just like showing you how water will flow. But this is how electric field will flow. And then we look at the density as a number of lines per unit area. Right? Number of lines per unit area, we call the density. Right? Stronger near the charge, further will be weaker, less lines per unit area. Right? And you should be able to recognize this one is a stronger field, this one is a weaker field, right? By the number of lines or the density of the line. Okay, so far, stop me if I'm going too fast.
A little bit fast lah, Che. Che, but what's
These
that
are
I
your
wanted to
SPM
ask?
work. These are all your SPM work. Refer to your SPM
Wait, Che.
textbook.
I wanted to ask, Che, that means the what is that? Going through the chapter, right? Che, how to say? Is it like I mean, among the SEM two, which one is the hardest topic answer?
Hardest topic will be AC, no? Depend on where you like the
Alternating
subject.
current.
Depend on which subject you like, which topic you like. Magnetic field can be
Oh,
also hard. So depend on what you like. You have to put in effort to learn, that's all. It's not a matter of easy or hard. Everything is
okay.
hard unless you put your mind to do a work. Then that's how you learn. No shortcut one. Okay?
Wait, quantity of charge C is greater, which is greater than on it. Correct lah, because the more they have, then their strength is sorry, I mean their density, right? And then
Density is just the
so
number
yeah,
of lines per unit area, that's all.
so that means this one will get stronger lah. So,
Yeah, you can see more lines per unit area.
yeah,
So C is stronger field.
C more than
A
B,
is
B
a
more
weaker
than A,
field.
so C is the strongest lah. Okay. Density representing the strongest speed lah. Okay.
Right? There's a positive and positive charge or negative and negative charge, repulsive force. Okay, this one is parallel and then neutral point is at the center here. Right? These are the other field, right? Where you have a positive charge and the surface there. Right? So that positive charge move that way. Remember the field lines repel each other. So there will be a positive end on the negative charge here, enter the surface perpendicular. Right? These two positive charge repulsive. This is quite called uniform field, which you'll study later on. Okay, so far we have looked at the picture to represent it, the magnitude of the field, where it's stronger, where it's weaker. Now we want to define. Right? Define how to measure the electric field. So we define it as force divided by charge. So usually the charge we use is positive charge. Right? Force per unit positive charge acting on a stationary point charge. So we imagine this is a charge. It creates a field around it. We want to find how strong is the field. We just put a test charge there. Right? Put a test charge there. That is your test charge. Q. A charge we place there is called a test charge. Q. And then we find the force on this test charge. So the force is that direction. That's the force, repulsive force. Measure that force. Measure the charge. That's how we calculate our F divided by Q. Not this charge. This is the one that contributes the field. We want to measure the field due to this charge. We put a test charge there. Measure the force. Force divided by the test charge. We get the magnitude of the strength of this field. Okay?
Yeah, okay. Wait, so the big, go back in. So that big positive sphere is nothing to do with the small one. The small one is
The
the
big
one
one is to
matters, right?
contribute to the field. We are not interested. It can be anything. We are interested how to measure the field. We just
I
put
mean,
a
we are
test
more
charge there,
interested on the
find the
I
force
mean,
on
we
the
are more
test charge,
interested on the
and
test
then
charge,
divide. That's all.
Yeah, we are more interested on the test charge and
On
its
the field,
electric
on the strength of the
created by
field.
created by the big one lah. That's it, right?
It doesn't matter what type of charge contribute to the field. We are interested to measure the field. So we put a test charge there. Find the force on the test charge, and the force divided by the size of the test charge is the magnitude of the field. That's all.
Okay.
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 Right. 10 minutes time, you have to change a new Zoom. How about the unit? force is in Newton. Right? Remember, we represent it with a symbol E, a vector. Right? That's why we make it so bold. And then force is in Newton. Right? Force is in Newton.
Oh, yeah.
Charge is in Coulomb. So it's Newton per Coulomb. And later on, we will also give the unit for you. It can be volt per meter.
Our.
Yeah, we'll go over, when we study that, we will go into that for you. Don't bother about that now. You just know that these
Yeah,
are
I mean the second term I have, right, the book, right? I told you, right,
yeah.
This is a very old book. This one 2012. That means before the new system came in.
That's why I say you must buy the latest one. Don't buy the old
No,
one.
which is good in a sense because they have the very old past year questions here, lah. That's what I
What's the
meant.
point? You don't have time to do so many questions.
No,
Old
usually they like to ask the hardest one, but
old syllabus may be harder.
no, I mean not the syllabus, the questions.
Question may be harder, yeah, because the old syllabus may be more challenging. That's why they remove it, make it a bit more simpler.
Oh.
Right? So alternative
Okay.
name for electric field strength will be electric field intensity. That's the old name. Or electric field. American tend to use electric field rather than electric field strength. Right? And remember, it's a vector quantity. Force is a vector, charge is a scalar. So electric field strength is a vector quantity. It means it has a size and a direction. Right? Let's look at the electric field of a point charge. Okay, there's a formula. You need to memorize it and use it. Know how to derive it. Right? That's why for test positive charge, the line of force goes out. E is electric field strength. Q is the charge of the point charge. R is the distance away. Right? There's a distance R. You want to know at this point there, what's the electric field strength given by this equation. And the direction is always a repulsive force. It's coming out along this line, the radius if you like. Radial. Okay with that? It's imagine you can put a test charge there, the test charge will be repelled. That's the direction of the force or electric field. Right? Same as your gravitational field. Where your gravitational field you use G. Right? Same. And then instead of M, you put Q. Instead of G, you put your 4 pi epsilon naught or 1 or K. And then R square is still the same. Right? It's non-uniform. That means if you look at the formula, as your R increases, your field becomes weaker and weaker.
Yeah,
right?
correct.
Mathematically, we say inverse square law. It decreases very fast with distance. How to derive? Right? Basically, first step, consider a charge Q. You want to know the field due to this charge Q at the distance R away. We can call this point there a distance R away as P, if you like. Right? You place a test charge there. Right? To find the derived electric field, you place a test charge there. Remember, we define electric field as the force on the test charge. So we put a test charge there to find the force. That's the test charge, Q. Find the force. The force is the repulsive force. Always we put a positive charge, not a negative charge. Then we know it's a repulsive force. And Coulomb's law tells us how to find the force, magnitude of the force, Coulomb's law. Okay, K, Q over R squared. Then after that, Coulomb's law gives us the magnitude. Then we go to the definition. definition of electric field strength is a force on the test charge divided by the magnitude of the test charge. That's all. So the force divided by the test charge. Small q cancel off. Then we get our answer. Okay. It's usually instead of 1/4 pi epsilon naught, I'll use k, easier, convenient. Yep. Okay or not?
Can do the derivation again.
First, we want to know the electric field due to discharge Q
Okay.
at a distance r away. So at that distance there, we put a test charge there, a small q. Right? Remember our definition? We find the force on this test charge, small q. That's what we do. That's your Coulomb's law. Then we use the definition to calculate our electric field strength. That's your definition, force divided by charge. So that's your force from Coulomb's law divided by the charge, q. So small q cancel off. We got kq over r squared. Yep, what's the problem? Yep. What's the problem?
Why? Oh, no mind. I got it ready. So you get kq over r square, that will be equal to. Oh, got it. Okay.
Yeah.
But why so like twisting here, twisting there? That's why I'm a bit confused already.
You just use Coulomb's law, calculate the force, and use the definition to calculate the field. That's all. Yeah.
Okay.
Okay, I think I'll let you digest. Take 5 minutes break while I start a new Zoom. Okay.
Okay. So what time did we start the class, huh?
You still got about 25 minutes, so.
Okay.